Our topic for today will be based on Chemistry 1502, that is organic chemistry. We are going to look at alkenes and alkynes. This is lesson 102. Let us start. The first lesson video on this topic, which is organic chemistry, we looked at the basics. We looked at the first functional group, which is alkanes. So in this lesson video, we are just going through alkenes and alkynes. And then lesson 103, we are going to look at alcohols and aldehydes. What we should know about alkenes: they have double bond between carbons. And then what we should know about alkynes: they have triple bond. So the only difference between alkanes, alkenes and alkynes is the number of bonds between the carbons. Now, looking at examples of alkenes, you can see that the postfix of this functional group is ENE, and then the postfix of this functional group is YNE. So the first compound will be a molecule having two carbons, and then there is double bond between the two carbons. Now, since alkenes and alkynes, they have more than one bond, then we cannot have the first compound from the alkanes, which is methane. So in this case, we have our first compound will be ethene, and then if we have a similar compound but from the alkynes, we are going to have ethyne. Now you can see the postfix, it's ENE, and then for alkynes it's YNE. We can look at more examples, but just a quick review from the first lesson video. Let us do comparison with the alkanes so that we can actually see the difference. Now, we said this one consists of only single bond. So looking at this similar compound from the alkanes, we are going to have C, and then we're going to have a single bond between the carbons, and then this is ethane. Looking at the postfix, you can see that we have ANE. Now, looking at more examples, we know that the next one will be something like this, which consists of 3 carbons, and then we can see that we have the double bond here to represent that, or to indicate that this compound belongs to alkenes. And then the name for this, we need to actually indicate the position of the double bond. Now, since the double bond is here, then by naming we are going to start from the closest carbon, which is this one, the carbon which is close to the double bond, and then naming this will be 1-propene. Well, it doesn't really matter, because if we have something like this, we will be forced to actually start from here, which the name will still be this one, 1-propene. Now, looking at the alkynes, we have 1, 2, 3. Then the name will be 1 propyne. Now the common mistakes that we normally do, we should make sure that carbon bonds 4 times. So as you can see that we have 1, 2, 3, 4. Then for this one we have 1, 2, 3, 4. So just make sure that when we bond a carbon we have a tetravalent. The next part that we need to go through is the general equations. Remember from the first lesson video, which is lesson 101, we talked about the general equation to predict the molecular formula of compounds. So the general formula of alkenes is CnH2n, and then for alkynes it's CnH2n minus 2. Now let's say, for example, we have something like this and then we want to determine the molecular formula. We can simply look at the number of carbons. We have 3 number of carbons, so N represents the number of carbons. From lesson 101 we talked about this. So we have C, where we see N we substitute by the number of carbons, which in this case is 3. Then we have H2 multiplied by 3. So in this case we have C3, 2 multiplied by 3 is 6. Then we count the number of hydrogen. Indeed we have 6 hydrogens. The procedure works the same way with alkynes. We can take a look at this example. Using the equation we can see that we have 1, 2, 3, 4 carbons. So where we see N from the general equation we can substitute by 4. So we have 4 H2, 4 minus 2. It's C4, 2 multiplied by 4 is 8. 8 minus 2, we actually have 6. But then we can check whether our structural formula is correct. 1, 2, 3, 4, 5, 6, 7. So you can see that when we use the general equation, it says the molecular formula is C4H6, but when we draw the structural formula we can see that there is a mistake. So this equation also assists us on verifying our structural formulas. So we can see that the problem is actually this carbon. Instead of bonding 4 times, we have actually an extra bonding which is incorrect. So we can quickly remove this bond and then we can see that we actually have 6. It's 1, 2, 3, 4, 5, 6. Let us quickly go through the line structures of these problems or these examples. The line structure of this compound, which is propene, will actually be like this. Now we know that from lesson 101, the ends of these lines we have our carbons. And then we can see that from the Lewis dot diagram, the first carbon consists of double bond. So we are going to put our double bond here. Then this represents propene. Now looking at alkynes, this is butane. And then we can see that the triple bond is on the first carbon. So drawing the line angled structure of butane, we are going to have 1, 2, 3, 4. So remember the ends, we have our carbons attached to every end. Now in this case you can see that the double bond is on the first, the triple bond is on the first carbon. So we are going to represent it using these lines. The other topic that we should look at is the condensed equations. Since we know the molecular equations or molecular formula for these particular examples, let us look at the condensed. Remember, the condensed is simply a summary that gives each and every detail on a particular carbon. Now you can see that we have 1, 2, 3 carbons. The first carbon, it has 2 hydrogen. The second carbon only has 1. Then the third carbon has 3. So this is the condensed formula for propene. Now looking at this, we have CH3. As you can see that the second carbon doesn't have any hydrogen bonded to it. Now let us look at more examples for the sake of practice. What is the name of this compound? Now we can see that we have a double bond, so it belongs from alkenes. And then we look at the number of carbons. We have 1, 2, 3, 4, 5, 6. Now we can also count from the side. Let's see, 1, 2, 3, 4, 5, 6. So you can see that whether we start from the left hand side going to the right, or from the right hand side going to the left, we still maintain the double bond on the third carbon. So we can see that our double bond is on the third carbon. So we are going to say 3. Now you can see that the parent chain, or the longest chain, we have 6 carbons, so it will be hex. That is our prefix, and then our postfix will end with E and E because it belongs from the alkenes, since we have double bond. So it's 3-hexene. Now remember, numbers, between numbers and words, there must be a hyphen. That is one of the rules. But we are going to look at these rules when we get to a lesson video, where we focus on the naming. When you are given a structure, how do we name? There are certain rules that we need to use to name these compounds. Let us look at another example. From lesson 101, it should be easy for you to actually answer this question. So we can see that there's no double bond, and then we simply need to check how many carbons do we have. 1, it's actually 1, 2, 3, 4, 5, 6, 7. So 7, you can see that the parent chain is 7. Then 7 is simply heptane, belongs from the alkanes. You can see that we only have single bonds. Now let's say the very same example, we add a double bond here. Now we need to actually start afresh when it comes to naming, but I can see that when we start from this side, this double bond, it seems to be closer compared to when we start this side, because when you say 1, 2, 3, 4, 5, 6, 7, you can see that the double bond is actually on the 4th carbon, but starting from this side, you can see that it's on the 3rd. So we need to start from the left hand side, and then the name for this, it will be 1, 2, 3, 3-heptene. What about this one? We need to start from the left, so it's 1, 2. You can see that the double bond is on the 2nd carbon, and then the number of carbon still the same, it's 7. So we have 1, 2, it's 2-heptane. What about this one? We have 1, 2, 3, 4, 5, 6. Now you can see that we have triple bond, and this triple bond is bonded to the 2nd carbon. Then we are going to have 2 hexane. Suppose we add another carbon here up to 8, so it's 6, 7, 8. Then we are going to have 2, no, it's not hex, remember 8 is oct, that is the prefix octi. That is basically how we write the IUPAC name for this. Now that's it for this lesson video. This is Wahula SJ. Thank you very much.